Okay, then I will start because I think what one of the things that I find particularly interesting in this context here is how to be able to transfer controllers between different labs if some kind of programming environment for describing controllers at the timescales that we are discussing. I think most of the time when we have said controllers here, we have meant supervisory controllers and not dynamic controllers. What is sort of the experience? Because I think you have discussed this as part of the project also. What sort of results have you reached as part of these discussions?
It was, if we are moving the controllers between labs, the biggest issue is, it's interfaces, but in system it's easy. But it's the topology of the lab. The AAT lab is totally different than our lab, so the time for integration took also that we explained to the student, we have a measuring point here, and this is how it's called, and this is how you access it, and also designing the experiment itself. So that was the effort.
Yeah.
But it was, he by accident developed it in Java, so we could connect it easily without any problems. And we sent him the interface in advance, so it was not much effort. The configuration and configuring the lab.
Yeah.
So we had to do those two things manually.
So the interfacing was done at the component level, so there was no high-level description of the controller itself that was transferred.
Yeah. And I think that's when you scope this, you said for the controllers we're interested in, if you take to the lowest time scales, you open the possibilities for different types of software interactions humongously. That means similar to the different levels of knowledge, you have more information here, not just data that goes in certain loops. That means there's no given structure. So trying to force something that is very open into a fixed structure, I don't think is very realistic. Where it really works, and where we see it also from the discussion with the basic automation, where you have the ladder diagrams or the function block diagrams. If you build up from the fast controllers and see, okay, have we described those? Can we come up to the next level? There's a promising development, but I don't see it happening for these, as you say, we're the ones that we're interested in, that are slower than a second or in this time range. Well, not at least as the next step, because it's too unstructured, too many different ways of organizing things.
It also depends on what you want to describe, how your control architecture looks like. If it's a supervisory controller, there is only one, and it's not such a big deal. But if there is a lot of actors and a lot of information exchange, if you have to, simulate or emulate DSO and aggregator and everything, then it becomes more complex, the description of the system.
What is relevant then, though? And I think that's something where the formal description still comes in, this discussion about validation. Okay, if you don't have a model for the code, because there's different ways of solving problems, you should still have a model of what you're actually trying to solve. So not for the solution itself, but for the problem, for the requirements. Because that's what we discussed this in the workshop in different places. And also now in follow-up projects, proposal discussions and so on. How can we make sure that when you've proven something in this lab, that it actually means the same in the other lab? So there I think the formal descriptions have a big potential.
But I think this way of working with a problem is not common in power systems, but having a higher level description, more higher level model.
Not yet.
Not yet, yeah, but it's not common. It's also difficult to explain it to people from power systems. Because it's more software engineering to,
I don't
at least for me.
I think it is also a thing that is coming simply because more it, yeah, software is part of it, but also that people want to do things in a market-based way, and if you want to do things in a market-based way, you have to specify what they should actually deliver, and you have to be able to verify that it has been delivered. So you will have a separation there that has not really existed before, that drives towards more formal descriptions.
Yeah, and in a way, this is just a direct consequence of liberalization.
I think
If you want to get paid for something, then you start having the business people talking to each other, and not the engineers anymore. So you have to, and then for that you have to describe the system.
And it should be suitable for lawyers too. Yeah, and I think that is a problem. I mean, the discussion comes up when you have a blackout, and you have to share the blame to somebody. Then
But should we do this only because of the lawyers? I think there are more practical motivations, and also for us. I don't know.
Yeah. Anybody else?
But even to understand somebody's algorithm, okay, there's mathematical equations, and you understand, but if you want to understand architecture, there's usually a picture with arrows. And I mean, it's difficult to understand.
I'm really tired of these block diagrams that just show an arrow, and they don't even say what the line means.
And yeah.
But that's, yeah. But this is common in the industry, the use case, the development approach. By now, and that was very fast over the last years, use case are now a smart grid standard way of describing it. When we started, I remember not when we started the project, but 3 years ago, less than 3 years ago, in the iPower project, use cases were not a word you would use in power systems. And some people used it, but no one could agree that that's actually our term. Later on we learned that we used another word and people didn't understand it, but if we would have called the same use case, people would have understood it. And we would have had a method. So we're hitting a software barrier, also in our own minds, for those people that are not suffering.
Someone else? Yeah?
You said a lot of labs are using nowadays the 61850, but none of your work here, none of the feasibility studies are in any way looking at 61850. Is there a reason for that, or?
Yeah. Okay, do you want person names or do you want an argument? Well, there has been a culture here about distinguishing the components' properties from what the component is supposed to do. So for a long time we believed that in a sort of service way of describing things, so that you can compare a wind turbine and a solar power plant in some sense, that they can both be fluctuating and both be curtailing. And more generally than developing such functional description as a basis also for doing, like for example, transactional control or these different things. So this thinking has been strong here for, I don't know how long to go back, but probably is in relationship to the founding of Cisco.
Yeah, I think
so there's been always a struggle with the 61850 model because that's strictly component oriented.
in the way that it is implemented now.
In the original conception.
Interpreted now.
Yeah, in the original conception, and then also in the way it's designed. But I mean, when you talk with people, then they say it's flexible to support it also. So anyway, that's why we haven't followed up so much on it, and we've been quite happy with just our own interfaces. It says in the survey for SysLab that we're now looking more into OpenADR, but then maybe the one who's been filling person form. So as a server approach, it's also something.
But there was also some try to implement the 615 system in FlexCon project.
Yeah, that.
Yes. So, but I was not part of it, but it was very difficult to implement this kind of interface because it was so detailed on the mechanical part of the, like wind turbines, so the so many of these components that you have to describe in order to describe the diagram. And we wanted to go to something easier for people coming to use that don't know the standard.
I can confirm it's hard to read and
Yes.
interpret. Sure.
And one thing is the standard specification, and another thing is the implementation, because they also, it's interpretation of the standard.
Yeah, see, simply for efficiency reasons, we never really spent the time necessary to implement it, because we could not really see the benefit from the uses that we were seeing for SysLab. There was not a lot of benefit from having 61H50. Yeah, other topics? I have another favorite topic, which is on how to lower the threshold for doing controllers in SysLab in particular. That's basically the system that I worries about. So I think we had just the other day we had a meeting where somebody from ISM wanted to implement a controller, and he realized that it was very difficult to get from what he had in running in MATLAB to actually have an implementation in a true way. It was disabled. Yeah. That step is very big because there's no sort of template controllers or no other way of actually getting over that step. What do you have any comments on discussions that you have had for doing that?
This is for us or maybe
For everybody. I mean, other people might also have some experiences in where they have implemented something in MATLAB or similar and want to try it out in SysLab and actually use one of the challenges very often come from doing in a distributed way. I'm sure you also have a fair share of problems in doing that. What is the I've also had some experiences.
My experience, I think this particular problem comes from that he wants to do it distributed,
Yes.
and we don't really have a framework for that working really well in
That
SysLab.
is actually not correct. The problem with him was that he designed sequential and then he wanted to do a distributed. So it's because he designed in MATLAB.
But this is Giuseppe's case.
Yeah, it
Yeah.
was.
We have discussed this a lot in the project, but I think it would be nice to hear if there are other cases also. I mean, it's really the distributed part that made it.
That's the real
And he
problem.
wasn't aware and had no awareness of that problem
Yeah.
when before they came. So that's more about understanding actually where the barriers, and we learned also, okay, there's a huge difference when you make a closed loop control. We describe it in a model, but there's no model for distributed control.
But for example, with Shui, I was part of the implementation in the lab, and for example, there was no problem with it being distributed. But one of the things was that we had no idea what the different controllers are doing at the same time, because the output of the controller was on a different machine, so we had to have several windows open to look at all the controllers to see what they are doing and which one was first. It was difficult for me to see what is going on in the system. So we would needed some visualization that would help us to even see what is
sort of
going on.
debugging support for
Yes,
such systems. Yeah.
Could you just have a kind of a supervisor not a supervisor, a monitor that monitors all the agents and kind of collects information, doesn't interfere with the system, but you just have
Yeah,
one.
we had this, but it was going like this so fast you could not read anything.
Okay. Okay, then you should kind of be able to
Filter.
filter.
Yeah. But it was,
filter.
but it was what was it? More than 10 of the units, and then all of them they were implemented the same, so they print out the same,
Yeah.
right? So they were all printing at the same time. So that's why it was so fast. And if you remove one line, it was still going fast. So, but there was some issues that we had, like normal things. And also another thing, she was implementing some feedback. So the unit was saying, I will, in 5 minutes, I will use this. Oh, right now I'm using this kilowatts. And by the time it came back to the controller, and controller decided to send it back, the unit was not consuming this exactly anymore. It was doing something else. So therefore, it was the control signal was not good enough anymore. It was not so optimal as it was in simulation, where sending signals takes no time.
Yeah.
So also this she noticed. Oh, then we have to fix this because it's no longer fit. So this kind of thing that when you are a control engineer, you don't think about communication or observability of all your system if you design it in one computer.
Well, there we're hitting a specific point. That's always going back to, you listed different features that are all features of distributed systems, and you meet that. So then that basically is the question back to you, Henrik. What's the when you asked the question, you didn't specify that it was about distributed or not distributed. And
I think it is not just about distributed. I think it is a general.
problems, they're all about distributed.
Yes, but I think in general, it is so that and it. I think we could benefit from having a number of sort of template controllers that do different things. A lot of what we have done, where it has been very successful and very easy to use, we have had a central controller connected to one computer, and the central controller has been running MATLAB, and people have developed all their stuff in MATLAB, and they have sort of just, yeah, that has proved to be very easy. But
that also means that you don't, as a control engineer, you don't actually have to leave your comfort zone.
Yeah.
I mean,
That
that does not solve the problem
No.
at all, because then you solve the problem by keeping the person where it was before.
but it could be
not
that you
address-
could extend that comfort zone and still and get closer to a control system that is deployable. I mean, it is not deployable to have, in Denmark at least, to have a single point of connection and have the whole power system run by a MATLAB controller. It would be nice. But that is actually perhaps that's a good way of formulating it. How can we sort of get closer to reality, to how things are being built in the real world, or could be built in the real world, and still have the threshold as low as possible? Because I mean, we have also experienced in several cases that it can be difficult to get people to do experiments, because it is seen as a very uncertain thing, that they don't have the same control over their environment as they have when they're simulating, and therefore they rather avoid it. And I think in that sense we are actually also not getting the results that we could have.
But the question goes then back, and let's not jump into distributed control right away. Let's ask other people here in the room who would like to deploy controllers or considering it, what are the other interests? Because if we hit the distributed control, we will talk in circle about all the distributed control aspects and complications. And I do think that we should be able to develop some tools to support also this type of development, but it takes a lot more. So what is the next step before we go distributed? Is it there's only MATLAB and then distributed, or what other things, what other features? If you have a central VPP, what does that take? That may be.
I think a first
Maybe
thing
like
which
each
could be
PhD
implemented in
student
SUSLA, for example, was OpenC UA, where you can actually implement the client in any language. I mean, here, the way SysLab works now, it's tied really to Java, and you need to know Java quite well. You need to know the system. If you could have an interface that, or protocol where the client could be made, say, in a non-specific language, Python or whatever, it would definitely lower the learning curve of doing things in SysLab, I think.
When you don't have to dig so deep.
Yeah.
That's true.
It was also one of the reasons we wanted to try out the VC.
Yeah.
Is there someone else who wants to do, like, present a use case? Someone who has or wants to deploy a controller?
Katerina, if you wanted to deploy controllers today,
I think that the Java would be the biggest problem.
But what if you
What
could
kind of
implement it
controller?
in, say, Python or
Yeah, then
in,
I think it would be much easier.
What kind of controller would that be? What kind of topologies?
I don't know. It's a hard
we should have something we can use.
a smart control?
So there's another argument for the standards-based interface, and that's the language independence.
I think it's a thing we should pursue.
Yeah, I think that's
Definitely.
a strong thing actually to go for.
Do we miss? I mean, when we do this, we will lose a lot of capabilities. I mean, Oliver's mentioned to me that when you use the MATLAB, yeah, but you don't really get the system. You only get this really narrow interface, and you're missing so much. But I don't know. Maybe that's a one.
No, this,
No, I
it's
think
not something realistic. I mean, why would you use MATLAB in the lab? It brings your controller to less realistic state than it is. How would you go from there to deploying the field?
yeah, I think
You cannot.
that's what he means. Yeah.
Yeah.
That you're not really benefiting from going to hardware.
In fact, we could support MATLAB on all the machines, but we don't want to because it's not realistic anymore.
Then we really should have some understanding of what is realistic and what is not.
No, I think the problem with that is that with the current setup you would have to add a computer at each of the nodes running MATLAB, and that is actually not really feasible. Yeah.
Now we have an interface that goes through Java as it connects to MATLAB, so it's also works.
Why would you need a MATLAB on your computer?
If you want to have several controllers, if you have only your controllers in MATLAB, then it could be just connected to the machines. But if you would like to put the code into separate machines, if you have I don't know, one
Just give me an example of controller that you couldn't actually manage from just one computer.
distributed MPC that Giuseppe was doing, right?
Yeah, but I mean.
Oh
more
yeah, you
in
could.
concrete.
Of course you could.
No,
But
and more in concrete, what do you mean? Sending power set point every 10 minutes, sending power set point every hour, sending power set points every second? What do you mean by distributed MPC?
When you distribute MPC, just means that the optimizations and the sort of the controller intelligence is separate between the nodes.
Yeah.
So they have to discuss with each other by an algorithm what should be their set points.
It simply means that there are decisions being made in all the participating components, and that's what you cannot do when you have the MATLAB way. Then you're only forwarding measurements through your MATLAB code, calculating something and distributing set points of decisions to the components. If you want in your algorithm to make local decisions on the different computers, you have to deploy something on each computer.
And perhaps the reaction of the algorithm would be parallel. So you would get two messages, two components would decide at the same time and send the message. So you cannot do that in MATLAB. I mean, you cannot have parallel execution. You cannot send a message. You can only share the data, right? You can access the data. But there's no. You could implement communication of some sort that if you send a message, 1 second is delivered. You could. But,
I think what he meant is that you run all those instances of MATLAB on one machine. You don't have to have them running it.
Yeah,
Yeah, okay, but then you use this distributed part of your system, and then you cannot say that your system works as a distributed system.
But actually
Because
that's,
it's sequential. I mean,
that's what you're doing.
if you have 5 components, and in MATLAB you say that they operate one after another,
Yeah,
and so like in distributed, they write to the whiteboard one after another, then you always have 1, 2, 3, 4, 5. One,
You
two,
could
three,
do
five.
this on
And in real world you have
Anna, there
five,
was a
two,
case
seven.
actually, Junji's thesis was a distributed system running all on one machine with 5 instances of MATLAB
yeah, but okay.
and then
okay.
communicating through
But
Java
then you
with each
will
other.
go multiprocessor machine can do that.
But I also know that for this kind of advanced controllers that nowadays people working on, like in US and in Switzerland, they are talking about how a device you can how to transfer MATLAB to a C language in a portable device, and this device can be installed on different equipment. You know.
Yeah, but
So
this is an integration, so you
Integration,
take
yeah.
one.
Yeah,
so
Then you're not designing a distributed control.
You do
And that exists, or
no, the controller is you design by yourself, but then you transfer that into by implementing it into a small portable device.
that exists for a long time. I mean, it's also many of the W has this. There's a different thing anyway. It's not can I ask another question before we
But
stick
I
with
mean,
this?
one question, just a second. Before entering in another question, please, let's just stay in this one a little while. So, I still cannot understand the limitation. I mean, you can run several activities in parallel in MATLAB. So, I mean, why can't you simply have all the intelligence instead of being distributed on each computer, just having the same model in MATLAB and emulating in some way by some delays the communication?
Yeah, I mean, basically the answer is, as with all other experiments, that you're doing some simplifications that might not be justified. I mean, that's why you want to test stuff in real world, because you don't know what it is that you are, what simplifications you're doing. You have to verify that, and by just integrating or assuming something and trying to emulate it might be completely wrong.
And one of the things that you're simplifying is when you do parallel processing in MATLAB, you can distribute to parallel processing, but it's procedural code. It will converge at the same point. It's part of the language. But if you have independent processes running, completely independent, then they're not synchronized automatically. So they make decisions independently. So the synchronization of, are we talking about the same thing that we make a decision about here? That's not something you include, at least in the normal thinking in MATLAB. I'm not sure if you can claim that it's impossible to model this in MATLAB, but at least the logic of this synchronization. But if you code it, it wouldn't appear by itself, the problem. That's the
But then you put a lot of
simplification.
effort in making this simulator of communication of wherever that you actually could avoid by just putting 2 things in different machines. Then you don't have to simulate anything.
Yeah, but that's also the point. I mean, what is your objective? Do you want to test the code, or do you want to test the let's say algorithm that is behind the code?
I
So
would like to
you want to
test
test the
the
capability that, I mean, how you are capable of coding things in real life, or you want to test the idea that is behind that?
I would like to test the idea, but in the setup that is the most realistic that I can get in the lab. Because that's the idea. That's why you come to a lab.
You can't
That's
code
why I
it,
don't do it in simulation only. Because I want a realistic setup.
Because it could actually be that by doing it in MATLAB, that you are missing something that when you deploy it in reality actually makes your algorithm infeasible. Yeah.
So what Giuseppe had is that he had a whiteboard and different components were writing to it. And of course he implemented sequentially, so there was one write, another wrote, another wrote. And in the normal implementation he had the concurrent read and write. And he didn't know that the 2 could write at the same time because his code was sequential, so he would never get it in his simulation if he didn't simulate.
Okay. I see your point.
Yeah.
But then, what would be the problem in just having MATLAB into machine? I mean, not all the people would like to learn Java.
Of course.
That's,
And we are not required.
That's exactly what we're talking about. If we
Okay.
can do it,
so,
if-
so I mean,
Yeah.
and I don't ask to have MATLAB in all the 25 nodes of syslab or OML, but just in the moment that you have MATLAB on two machines, then you can recreate exactly the same problem that you were addressing, saying that you cannot see this kind of problem if you are running multiple threads in your same computer. Then the moment you have two machines where you split part of the burden, then you have also communication between the machines, then it's
Yeah, you could do that. It's possible.
but I think it is on the. I mean, that way of arguing very quickly eliminates any need for experimental work. I mean,
say it again.
Don't say that because then you have to touch all the buttons.
yeah.
No, I didn't get your last sentence. Sorry.
I think you should be careful following that line of reasoning, because very quickly you eliminate the need for doing experimental work, because that is exactly the point with experimental work, that by building it for real you discover things that you didn't expect. That is the whole point.
Yeah.
So you have to build it
Yeah.
for real.
Okay.
And that is what we are trying, and I mean that is the whole point.
That is also why the experiments in lab are more valuable than the simulation itself,
Indeed.
right? Because it's
But then you would go implement it in MATLAB and then put it in the lab, and you would say, but I've simulated it in the lab. You see lots of things like that. So I think I would really like to just move on because
Because we have minus 13 minutes.
Yes. But there's other really important things, and we just stuck on this one question, and that's kind of. There's
But I think
really
it is-
important aspects. So this can be summarized with, okay, what do we mean with maturity? How mature is the controller? Can we define these templates? And ticks these boxes, like does it synchronize and so on. There's a completely different aspect that I find is very important here, and that was about data sharing and databases. So I would like to know how many algorithms and how much data sharing is actually feasible. I mean, at the moment you look up for your flat files and you do everything. I would actually like to ask Anas about that also. We have one discussion where we look at when I want to make a controller that looks at forecast and or at data from other places, do we have simulation cases where we need database access, historical database access? And what would be a way of implementing that and simplifying that? Is the flat files really the best solutions, or what can be done about? Yeah, flat file.
Yeah,
Flat file.
What is that?
Huh?
To define flat file?
Yeah, like
The CSV files that you
Okay, just the text files.
text file.
Okay.
So
I guess
if you have a controller that does more some predictive controller, so it has to be more historical data. We have cases where this needs to be done, and what approach would be right to do this?
for example, for weather, the services that you ask for temperature or whatever, so you could ask for something that the service would give it back to you, or just the data. You don't have to look in the whole database by yourself, or know where's the file. Perhaps the
That's
service
exactly so. We have
available
we outline three options. One is look for the file, know where it's stored, and just read it in the right place. Second is have an SQL database, and you would write SQL query. And the third one is a service. Which interface is the best for our purposes?
There are infinitely more options. than just
Yeah,
those
yeah, but
three.
Yeah.
probably, but
It depends on the application. If you just need one value, then the service would be the fastest,
Mm.
because you don't have to look for it.
So the rate controllers are using those services in the database.
And do we run into problems with the flat files, or should we just keep it?
The files are available. I mean, it's a text file that you have to look through. The database
Yeah, and
is
pass
fast.
and import. I mean, we don't really use that in Susha. Not to my
Not real
knowledge.
time, just the later for
Only for
analysis.
configuration.
So if we have, for example, more visualizations happening, so if you want to actually visualize the historic data and so on, interact with it. In the lecture project, we want to do some operating support things. Then you need historical data on a more, not on a very high fast sampling rate, but you need access to it. Will we then need some other approach than the text files?
But we're already doing that with databases.
Which is, yeah, exactly, storing
Um,
database.
I was just a little lost on whether or not you're talking about
I don't know.
visualizations or general
I
analysis,
don't
or whether or
see
not
any-
you're doing real-time control. There is a gap of about 24 hours today between the historic data and the data that's being logged right now.
I mean the short-term historical database, so looking the last 5 minutes or last hour,
Yeah,
or
but-
scaling even between the last 10 seconds and the last 5 hours. I want to make progress about that. You said you're doing this already, right?
Well, we're doing it for the historic data that goes back from 24 hours, from yesterday and backwards. There is no framework right now for collecting that fast historic data on a generic way. You have to access the nodes individually. Right now, you probably have to manually pull for the data and keep your own. I mean, I don't think there's any access to the log being written right now on the node. We have to set up some other framework for that.
It doesn't make sense in our distributed setup.
If it's something that is required, I think it's something we should look into. If we can do it. Yeah.
But in fact, we didn't mention it. It was whenever we do experiment, we always look at the visualization of some sort. So you need to look at the data from the system. So I think visualizations are very important for the experiments. Always.
Yeah, but if you're doing some analysis just to see the historic data, then you see it once, then the CSV files can be okay. If you have some visualization that's continually running, then some kind of database or cache system would be much more ideal. It depends.
I think we will have to close it now
Yeah.
before.
Yeah, is the web stream still running? Is the web stream still running?
Of course.
Oh,
Yeah. Good. But I would like to thank you all for coming here, and I would like to thank the presenters. I think it has been an interesting half day. It was nice to be updated, and I hope that the other people here also enjoyed that. So thank you all for coming.